You can load your. Yeah. Auto rotate. ठीक है, ले लेते हैं. We just can introduce you. Okay. To post this particular session, now we'll move on to our next session, where the ITF results that have been performed by our team will be presented. So to present this particular one, we like to invite Engineer Rajesh Shibar. So Engineer Rajesh Shibar is currently pursuing his PhD from the Department of Civil Engineering of Indian Institute of Technology, Kharagpur, as a Prime Minister Research Fellow. He had also completed his MTech from the same institution in the specialization of environmental engineering and management. Mr. Ba has completed his BTech from the National Institute of Technology, Amirpur. Mr. Ba's current research interests include thermochemical hydrogen production via aqueous phase reforms, biocarbon synthesis by hydrothermal carbonization of waste streams, application of life cycle assessment for achieving sustainable goals. He is one of the young professionals who is budging out in the domain of life cycle assessment and one of the think tanks in our research laboratory. So now I'd like to welcome Rajesh Shibar to present our research results.
Thank you, Dr. Ravi, for giving such a wonderful introduction. I'll just take a few moments to get my slides ready. Okay, fine. So I guess the slides are visible in both online as well as here it is visible. So I will start my presentation. So basically, I'm going to share with everyone the findings of our collaboration with ITF, basically based on biofuel. Mostly it is on biofuel, and then a brief on the vehicular component as well. And as you can see that it is titled as Sustainability Assessment. No, sorry, this is Professor Dubey's. Just pardon me. Okay. Yeah, this one. Fine. So yes, this is the correct one. So the title of my presentation will be Supporting the Life Cycle Assessment Activities to Decarbonize the Indian Transport Sector. So as you have already seen from the morning sessions and up till now, this entire exercise was done under the leadership of Dr. Brajesh Kumar Dubey, Dr. Ravi Shankarchila, and I also led a hand to this. Then starting with this, like why do we have to organize this workshop? So as you can clearly see from this particular slide, that it tells that there is a chance, like as things are going as of now, like various reports have already said that about in next 20 years, if things are as usual, 20-30 years, we are going to see a temperature rise of 4 degrees centigrade. And already we are suffering the impacts of this intense heat wave. And you can imagine that as the time goes on, how intense it can be. In fact, several other studies have also stated that if we do take measures to actually combat it, then also there is a chance that in next 60 years, it can still rise by 4 degrees Celsius. So it clearly indicates that how important it is for us to immediately address various components which are causing an increase in global warming. So from this particular slide, you can see that it is already expected that if things go on as they are, millions of deaths we are going to face due to air pollution, due to waterborne diseases, hungers, famines. So this is one aspect. And apart from that, we can also see that there is going to be a $2 to $4 billion loss to the global economy by 2030. So this is the impact of global climate change that we are going to see. Now, how the GHGs are getting impacted. So in this particular slide, you can see that currently, as of 2020 or 2019, this data is, we are seeing a 50 billion tons of carbon dioxide equivalent is being released each year. And the trend is continuously increasing. And among this entire set of emissions, you can see that on the right-hand side, in the figure, I have shown that which sectors are contributing how much to these emissions, and 15% is what it is coming from transportation sector. So it is quite significant to address this particular area. And this is another emission data coming from different economies. You can see that in developed parts of the world like US, this green colored one is from US. Then other developed countries are also having such a trend where after 2000s or before that also, the emissions from these countries, they are on a downward trend. And this is quite expected because they have achieved the developed stage, and after that they have the capability to work on decarbonizing the economies. On the other hand, if I look at the more developing countries or economies, we can see that this one, it is China, who is actually facing first as going through an increasing trend of GHG emissions. Similar is the trend for India also. You can see that this yellowish kind of line, it is India. So since we are kind of going towards a developed nation, so it is expected by, if I look at the past data, that we are going to see that the GHG emissions from our side is going to be more than the Western nations who are already developed. But that excuse doesn't work always, and we have to do something, because just by saying that we want to get developed, it doesn't mean that we can just blindly go on giving GHG emissions into the environment just because in the past other economies had done so. So that is why our government is taking serious measures to combat this issue by influencing or by promoting the solar power as of now, then hydropower, then hydrogen energy is another area. So like that, our government is taking various steps to reduce the carbon footprint all across our country. Then this is another area. You can see that in terms of a cumulative impact, wherein China is currently having the highest GHG emissions, followed by US, European Union, and India comes at a 4th position. Now, since one of the major reasons for these emissions is fossil fuels, so that is why we often hear that we need to shift towards renewable, clean or green sources of energy. So sometimes what happens, we use these terms synonymously, but I just wanted to give a brief definition of or overview like what these are. So renewable, as the name suggests, that it is basically a renewable source that gets replenished at a rate which is higher than what it is being consumed at. On the other hand, clean energy, as the name itself derives, it is a source of energy that is clean, like it doesn't emit any pollutants after being combusted. While green energy is something that can be an agglomeration of both renewable and clean. So what happens is that in green energy, the natural green sources of low impact, these are the what we are looking at. This is another pie chart, kind of, not pie chart. This is another chart that you can see here, that green energy is this area, geothermal, wind, solar, these are all coming under green. Then renewable is like large hydropower, they are coming under renewable, municipal solid waste, and hydrogen and fuel cells from certain feedstocks, while conventional ones are these nuclear, natural gas, and fossils. So the clean energy is somewhere which is common between all these three areas. Now, in terms of the vehicles, as Dr. Ravi has already highlighted, that we are seeing that as of now, there is an increasing trend in the two-wheelers, which is expected to go down after 2035, round about that. On the other hand, the four-wheelers, it is going to be continuously increasing till 2050, and in fact, after that also, which is quite expected based on the GDP growth of various economies. Then this is another chart which shows how the Indian automotive market demand is going through. You can see that it has fallen a bit during this Corona area, or the period when we were faced by the Corona pandemic, COVID pandemic. Then after that, as the economy started to bounce back, there is again a jump in the demand for these automotives, among which most of one is being this hatchback. Now, another one is, this is another way to depict it based on the type of fuel that a vehicle is being run at. And you can see that this is business as usual scenario. If we don't take any measures for the future and let things go just they are, then we actually see that it is mostly going to be dependent on the liquid fuels, that is mostly oil and diesel, like petroleum and diesel. Now, in this particular one, this is not business as usual. It is what we are expecting to see as we take several measures to reduce the carbon footprint. Here you can see that the oil, its footprint is expected to reduce as the years go forth. Then on the other hand, electricity driven vehicles, e-vehicles, their presence is going to increase along with other renewables as well. This is another figure which shows the growing demand of vehicles based on the type of fuel that is being run at. At 2030, you can see that this electric and this liquid fuels, this is having some presence. And as the time goes on, CNG is also starting to show its. Okay, so this is, sorry. So this light green and dark green one, this is liquid and electric, which is showing its presence in two-wheelers in 2030. And as the time goes forth in 2040, you can see that electric is having a much higher presence as compared to the liquid fuels. And similar is the case for other scenarios as well, other types of vehicles. Now, coming to our country. So as of now, we have already seen that India has become the most populated nation in the world with a population of exceeding 1.4 billion. And in terms of oil importer, it is the third largest crude oil importer. And among the crude oil that is imported and refined, 70% of the diesel that is being produced, it directly goes into the transportation sector, while almost 100% of the petroleum that is being produced, it also goes into the same. So that clearly shows that how much this transportation area is dependent on these fossil fuels. And on the right-hand side, you can see that what is its impact is. Like globally speaking, we are going to see, we are already seeing more than 4 billion tons of CO2 emissions per year, and of which this transportation sector is accounting for 10%, which is quite significant. And out of that 10%, road transport itself is contributing around 87%. So this clearly indicates how significant this road transport sector is. Then when people talk about various solutions, we often hear the keywords like biofuels, electric vehicles, hydrogen energy, refining the vehicle design, reducing its weight, preferring to walk or bicycle, or using public modes of transport, or optimized routing as well. And in order to actually assess how the environmental performance of a certain plan is, we perform life cycle assessment, which is one of the pathways. And our previous speakers have already highlighted in quite some detail how to perform this LC and what are its importance. Now, talking about the project scope and components of our collaboration with ITF, what we actually did is that we focused on two basic components. One was the biofuel component, which was our major interest. Then we also looked at the vehicular component. And I would like to highlight that both of these components were being looked at from Indian perspective. We particularly looked at those studies which were done in India and having Indian data, because the basic goal of this study was that we wanted to prepare a database of this biofuel component and vehicular component, which will feed into the Indian system, so that going forth, whenever other studies on LCA can be done, they can refer to a database which is for Indian scenario. So that is what we tried to do. And in terms of the biofuel component, we particularly focused at bioethanol and biodiesel. While in terms of vehicular component, in ICEVs, we looked at its manufacturing, assembly, delivery, and end of life phase. We didn't go into the combustion phase or the running phase of the vehicle. Then again, in terms of the e-vehicles, we looked into the manufacturing of the lithium-ion batteries. So this is in turn the slide which shows that what we exactly did, the same thing which I've already highlighted before. And another part is that in here you can see that while doing all this exercise, our another goal was that the GREET model, which Dr. Ravi had highlighted a few moments before, and I will also share in the next slide, it already works intensively on this transportation sector, on performing the LCA or environmental footprint of this transportation sector. So we had to collect the data and work it out in such a way that it can be fed into the GREET model, into the system boundary of the GREET model. Another component of this particular, our collaboration with ITF was capacity building, so that we can engage with various stakeholders, spread awareness about the importance of decarbonizing India's economy in particular in transport sector, and discussing like how we can fast track this, how we can plug various loopholes, various research gaps, or actually on-field gaps that we see while implementing these concepts. This is the GREET model that we have already been introduced by Dr. Ravi. And this is the system boundary. I'm going a bit quicker because we are heading towards the end of this day one. So I will just fast track it. Yeah. And coming to the studies that we looked at, it was basically a literature review where we found that 19 studies were there, which pertain to Indian subcontinent conditions relating to biodiesel, while 17 were for bioethanol. So this is what we found. And in terms of the vehicular component, there also we have seen that it is promising to see that various studies related to the LCA of Indian vehicular system, it is coming up in terms of different fuels. But since it was not as much available as compared to the biofuel component, we also took a look at various other countries and economics around the globe so that it will be easy to compare between these countries and how the system works there. In terms of the biofuel component, you can see that while collecting the data, we were very particular about the fertilizer amount being used, pesticides, herbicides, diesel, and electricity consumption. While in terms of the vehicular component, we looked at the vehicle lifetime. We considered the lifetime mileage, the batteries, weight, and various components of the vehicle weights. This also is what we recorded. Then once we went through all this data, we didn't derive the footprint. We actually saw that what different studies did, what was their results, and we compared those studies with each other. In certain instances, what happened is that we didn't have as much data as required to really arrive at an average. So we, in here, you can see that allocation technique, the importance of this allocation has already been highlighted by my previous speaker. So there are various allocation techniques. In here, you can see economic, mass, and energy allocation, which is the most commonly used one. Apart from which, there is a system expansion and substitution approach also. So economic allocation is the most commonly used one because of the importance given to the economy. So that is why, based on that, fossil energy intensity for fuel production per megajoule of biofuel produced was found to be 0.16 for bioethanol, 0.16 megajoule of energy, fossil energy invested per megajoule of bioethanol production. And in terms of total well-to-tank energy intensity, it was 0.35. Now coming to the global warming footprint for per megajoule of fuel production, it was 19.64 grams CO2 equivalent. So this was that we found. And when we compared it with different studies and we went through them, we saw that the bioethanol production phase, it was having the highest footprint, followed by the cultivation phase and the collection phase. Now mind it that this trend was observed for most of the lignocellulosic feedstocks except sugarcane, molasses. Now why it is that, if I will explain you in the next few slides by giving an example. Here you can see in here that when we are talking about producing ethanol from sugarcane molasses, the step is this. First, sugarcane farming takes place, then sugarcane transport, then sugar production. Now during sugar production, our main product is this sugar along with others, and then molasses is also another product that goes down the line to form ethanol. So in here, both sugar and molasses is having an economic value. And so when we do an economic allocation, a significant part of the impact, it is allocated to molasses due to its importance. So that is why in terms of producing ethanol from molasses, we are seeing that ethanol is having a higher footprint as compared to the one that we generate from lignocellulosic residues like rice straw. So in here, you can see that since this molasses is being used for ethanol production, here you can see that the farming stage is having the highest impact. The reason behind this is that in farming, we use various fertilizers, pesticides, diesel pumps are being used. And since molasses is a product that we are assuming from sugar manufacturing, so that product is also having some footprint because we had to cultivate, we had to do agricultural activities to produce that product. So that agricultural phase is also to be accounted for. So that is why in here, farming phase is having the higher footprint. Now, if I look into the rice straw, which is not similar to molasses, like molasses is more like treated as a product, but rice straw is more like a residue coming from this rice cultivation. So that is why most often we see that we don't actually attribute the impacts of rice cultivation to rice straw. We use it as a residue and then go forth and look into the various steps like feedstock. It starts from feedstock collection, then transportation, and then further processes. So you can see in here that the farming phase is not included into the system boundary. However, let me just highlight the point that as we go forth, if we see that there is an increase in economic importance of the straw, its value is getting somewhere closer to the actual rice grains, or it is coming statistically significant, then at those instances, it might become important to include the cultivation stage also into the system boundary. And then we can see a case similar to the use of molasses for ethanol production. So here you can see that by excluding cultivation phase from the system boundary, the ethanol produced is having the highest footprint from this enzymatic hydrolysis. And these are various modified pre-treatment methods, and this is one is the conventional pre-treatment method, this column. And in all of that, you can see that the enzymatic hydrolysis along with other pre-treatment processes, they are mostly accounting for the GHG emissions. Then coming to the various kinds of feedstocks that being used that Dr. Ravi has already shared. So current trend is people are mostly relying on molasses for for ethanol production. And in terms of economics also, the production of ethanol from molasses is quite cheaper than as compared to others. Then looking into the government policy, the government reports they are trying to emphasize more on the damaged food grains or surplus rice or maize, or particularly non-food feedstocks are also being looked at. And if I talk about the annual availability, then in that case, sugarcane, as we know that it is the most available one, followed by other feedstocks. So now going into the biodiesel component. So in biodiesel component, also I am highlighting the economic allocation because of its importance. So in here, I have not provided the value for this fossil fuel intensity, energy intensity, because the data, only one data we had for that, which was not sufficient to show an average. So rather, I am showing you the energy intensity in terms of whole well to tank, which is 0.51 megajoules of energy is being used to produce 1 megajoule of biodiesel. On the other hand, the carbon dioxide footprint is 30.78 gram per megajoule of biodiesel production. Now, in terms of the feedstock being used, by looking at the policy and both availability, we are looking more towards palm oil based feedstock for biodiesel production. And then Jatropha is also being looked at along with used cooking oils. Now in here also, the most of the impact, if I am talking about these lignocellulosic feedstock like Jatropha, Karanja, if they are being cultivated, then obviously cultivation phase is having the higher footprint, followed by biodiesel production, and then the collection and transportation phase. But if I look at the third generation feedstock like microalgae and yeast, in there we see that the biodiesel production is having higher footprint as compared to the feedstock production or cultivation. So this is one such example, a case study where you can see that the microalgae is being cultivated through two sources. One is wastewater, it is compared, which is already having nutrients, and another is the freshwater process input, where due to the absence of nutrients, we have to add nutrients like diammonium phosphate and urea externally. So these two processes were compared scenarios where the process starts at cultivation, then flocculation, various centrifugation, extraction, and then transesterification for biodiesel production. So when I looked into this, we found that the global warming footprint, when we used FWA's fresh water, it was highest for extraction, and cultivation was also somewhere similar. But when we used wastewater, in those instances, the extraction phase was having higher footprint and cultivation phase is having lower footprint, because we have avoided the extra nutrient supply that was earlier needed, and in case of using fresh water for this microalgae production. Now, this is another in terms of the energy footprint also, an extraction phase, or you can say that the biodiesel production phase, that is having higher footprint as compared to the cultivation and flocculation phase. So this is another example of microalgae. And then Jatropha. Now in here, I would like to highlight that this study was done back in the year 2013. And interestingly, at that time, what we found is that the cultivation phase was having a higher impact than the other phases. This can be due to, because you can see on the left-hand side that they were adding nutrients, electricity, and water and all during the cultivation stage, particularly the nutrients and carbon dioxide was being added. So extra energy was being invested for that. And in case of Jatropha, the footprint was actually lower than that of microalgae. So these things can vary based on the electricity mix that people are using, that has varied significantly back from 2013 till today. So that can be one reason why we are seeing a change in data. And this also highlights why there have to be a number of studies on such areas from Indian context, so that we can get a consolidated value that we can rely upon and say confidently that yes, biodiesel is having a higher footprint or lower footprint, traditionally a lower footprint than other jet or Karanja based biodiesel production. Now, coming to the vehicular components, in vehicular, we found that the highest footprint was due to maintenance. And just to highlight that, we didn't look into the application phase or the fuel combustion phase. We were particularly looking at the production, assembly, and then this maintenance phase and end of life phase. So in that, obviously, production had the highest GHG footprint. And in terms of lithium-ion batteries, here we saw that based on the type of battery being used, the footprint usually varied between 14 to 47 gram of CO2 equivalent per kilometer of distance traveled. And in terms of the conclusion, the project goals were data collection and structuring, engaging with different stakeholders, spreading awareness, and also process hotspots that we wanted to identify and highlight. In cultivation was there, both in terms of biodiesel and in terms of bioethanol also, for in terms of molasses, while for other lignocellulosic residues, the biorefinery area was having the higher footprint. So we need to like address that part and refine the biorefinery activities. Then manufacturing process in vehicular component, this was another area that was having higher feedstock. So we need to use components for vehicle production, like using lighter weight components to reduce the overall footprint. Then recommendations was using third generation feedstock for biodiesel and refining the various activities going on for bioethanol production, so that they can have a lower environmental footprint, and optimizing the modeling and maintenance of the vehicles. Also, the most important part, that we need to collect data for Indian conditions in a very structured manner. So this was all, and thank you for your attention. Yeah, so thank you. So we have reached 5 p.m. We tried to, like our scheduled time was also 5. If you have any questions, you are free to put them in the chat box. If you have any questions, you can please unmute yourselves, or you can also type your, or in fact, if you have any suggestions on today's session, that also you can put in the chat box, or in fact, you can also share that by unmuting yourself. Hello.
So delegates, we have 30 minutes time for discussion. So any questions from the participants? Chitranjan Dalia, he is also not, is muted. See, in the full day, either from the morning till now, any questions? It looks like everybody is clear with the aspects. Okay, it's like you can share your experience also. Yes. Yeah, yes. Just come here.
It is mentioned that the component was manufacturing part as well alongside the biofuels that we are using for the vehicles. So, like, I want to understand, is there a different design for the EV vehicle as compared to the biofuels that are there? And if so, if we are like transitioning from the conventional fuels right now, how this distribution like biofuels or the vehicle, how
So in terms of this collaboration, we basically looked in both EVs and this ICEVs. In ICEVs, we particularly looked into the assembly part, various components, and in EVs, we particularly looked at those lithium-ion batteries, because traditionally we have seen that they are having important or very significant footprint because of the mining activities that take place. So how to transition between this current one, full-based one to EV one? This has already been like our previous speakers were quite experienced there, as they have mentioned that the shift should be gradual. Like as of now, we are dependent more on coal, and as our economy transitions towards a solar-based one or other renewable-based one with a suitable plan for their end of life of solars as well, that can be more suitable for shifting towards EVs. And we, as of now, don't have suitable infrastructure also for various public, like private ownership of EV vehicles, charging stations and all. So from my brief experience, that what I have being in the circle of other eminent figures, so I have learned this much. Thank you for your question. So any other input or any advice to our team, it is highly welcome. Otherwise, we can close today's session. Yeah.
Karthik, all the sessions are very information. Be critical. So hopefully, we will be one of the think tanks of Helsinki. Everybody is silent.
Just to highlight a point that in the upcoming sessions from tomorrow and till 23rd, we will be having speakers from industries as well as other active people who are actively working on this area. So just note that you can gain a lot of experience from that. And if you have any kind of doubt, let it be on a technical side or an economic side or a practical aspect, it will be very helpful if you can put forth in this platform, so that if there is something really important comes out of that, we can really address that issue on different levels. Thank you.
Okay. So feel free to ask questions. Keep the child in you alive. Right? Do ask multiple questions. To pose questions, put forward many aspects. So hopefully you had a full day meal for today. Let's recharge and energize for tomorrow's session. So tomorrow the day session will be opened by Professor Brajesh Dubey, and then followed up by Dr. Sarath Gutkonda with 2 back-to-back sessions on transport policy and data emissions, followed by case studies. So have a nice evening, have a rechargeful evening, and let's meet tomorrow. So let's wrap up the day for today.